Hi, everyone. Good evening, and welcome to our live talk about the MITRE ATT&CK Framework for Kubernetes and Container Runtime Security Posture. My name is Ariel Schuper, and I'm VP Product Management in Portshift. Together with me is Zohar Kaufman. Hi, Zohar. Good evening.
Hi, Ariel.
Good evening locally. Good morning or good afternoon, everyone else. Zohar, are you ready to talk about the MITRE ATT&CK?
Sure. I'm sure that we'll have a great talk today.
Great. I hope I pronounce it correctly. So let's start. So when we want to start, we want to talk about MITRE and ATT&CK and Kubernetes runtime. We first need to understand the background. Where are we starting from? The different attacks, vulnerabilities. What are we up or what are we against to? So when we look, and examine, the different vulnerabilities, and this is kind of a nice infographic that I usually borrow from Sysdig, so the courtesy belongs to them. You can see like a whole, scale of attacks, different attacks or different vulnerabilities in different stages. Zohar, what's interesting here in this, scale? The interesting thing here is that it's not just the application code. So, we are familiar to the application code, we're familiar to scan images, we try and we build or compile them. And interesting, you can see here that a lot of the significant attacks doesn't come from the images. It doesn't come from our application, from the applicative code. They're coming from, the runc, the Kubernetes runtime. They're coming from the dashboard, the API server, or just, the kubelet. So the many pieces, there are many elements in the Kubernetes cluster which make, the security posture something which is a little bit more complicated and not as simple as easy, to track and to manage. I don't know if someone thinks it's easy, but we definitely see here that it kind of cover a very broad spectrum. I think this is something, we all need to keep in mind when we are thinking about, securing Kubernetes spaces. Now, if we move beyond that and we're looking recent vulnerabilities, we see that the things that keep coming in. I mean, do you remember the malware or the CVE that was discovered just 2 weeks ago? So if you remember, we just found out this recent CVE. That was, I think, was the big I would say the public disclaimer came from Google Cloud. About the CVE 2020-14-36-38-6, and this vulnerability which allow regular containers to obtain root privileges if they manage or successfully exploit this memory corruption. But it was not the only CVE that we found out recently. We kept seeing CVEs even before. In June there were 2 CVEs in Medium. I think the recent one was on a high level. This is why it's a bit more notable. But CVs are keep coming in and keep popping in, and I think that we need to remember that even if all these CVs make those headlines, and the one we remember famous blogs and a lot of talk about them, behind the scene there are more things that we need to consider, and this brings me to talk about what I call the containers attack anatomy. And this anatomy is, what happens, post-vulnerability exploitation. So we talk a lot about vulnerability. We talk a lot about potential exploitation. But what happened afterwards? Are we done, when there is an exploitation? And interestingly, when you analyze how attackers behave or what they do, you can see that there are 2 main patterns, we can look at. So the first pattern is like, when first attackers are successfully exploiting a vulnerability which they discover. They're trying to look for permissions and trying to see what they can do, with the object they breach. In our case, we're talking about containers. We're talking about processes which are running on the host. They try to see, what are the things, that they can do, what permission they grant. Then they'll start moving to expand their attack potential and see even, if they're happy with what they found. That's great. But if they're not, they try looking for, more, whether, they can escalate the privileges, and and reach the host, whether they can, escape from the container and reach other containers, or reach the host, and from the host they can reach other hosts, in the same cluster, or even just, reach all the cluster resources. And ideally, when we look at analyze different attacks, or look at different, famous attacks that happen, usually we see two patterns. Either attackers are trying to abuse the cluster resources. And in this case, if they want to abuse it for crypto mining, for example, they need to go beyond the specific pod which they managed to exploit. Or they were trying to look for the Holy Grail, trying to get some access or passcode or credentials or token that will allow them to connect to the database and exploit the data which exists on database, or the storage, or whatever the Holy Grail which they mark as their potential attack option. And when we look about this anatomy, that means that we need to prepare. We need to make sure that our security posture can address this, the thing which goes beyond. And I think, when we analyze this part, the intermediate conclusion is that we need a risk assessment for Kubernetes. We need a tool, that can look at all the steps. It doesn't just stop at vulnerability. It doesn't just stop, when preventing the first exploitation, but we need to cover all the different aspects of those attacks. We'll look about, we need to get the context. We need to understand where we are, what are the things which can go wrong, or what are the problems. And from there, we need to carve our security. What do you think about that?
I think you covered it very nicely, and I think we should give an example later on.
Yep, I agree. And I think this is, the purpose of, our talk is what I think is, let's first start analyzing what there is today, what exists today, which will allow us, kind of to deep dive afterwards into our the different demos or that we want to do. Right. So, when you look today at what exists or what people use for risk assessment, then obviously the CIS benchmark for Kubernetes are what sticks up, quickly, or what sticks up is the most notable benchmark tests of, risk assessment for Kubernetes clusters. Now, the CIS stands, for Center of Internet Security. It's a very famous and respectable institute which has a lot of different benchmark or different recommendation, and they're using the same pattern. It's an objective, so they have no agenda, no product to promote. It's their own. It's completely objective, consensus driven, so everyone can contribute. Every voice can be heard. And it's creating security guidelines. And in Kubernetes, there is few revisions, few versions. They update the benchmark based on the Kubernetes version, and they consist of multiple recommendations on best practices configurations. Now, those are secured configurations. We know that security misconfiguration is still accountable for most of the security incidents that there are, but in essence, we're talking about secure configuration for all the Kubernetes elements. Could be the master node, the worker node, the etcd, making sure that you have policies in place. But it's all about, how to set the scene. It's a very robust, very large set of tests. It's, I think, above 100 tests, having different checks, and it really cover all the different elements. But you know what? What are the challenges, or the few challenges I see in those benchmarks, which again are super comprehensive and complete, is that you get a little bit lost, when you're trying to analyze or trying to assess, where you are in terms of your security posture. Because, as I said, there's a lot of tests. Most of them are scored, some of them are not scored. So it's always kind of hard to tell if the failure, because it's not scored, mean that you are secure, or if it's not scored, mean that you don't need to worry about it. There is level 1 and level 2. Okay, so there's different levels. it can get a little bit mixed up, where you are and what is, what's the main impact on your security based on those results. But it's not the only challenge that I personally see in those benchmark. I mean, I think that the focus on configuration is very important. I think the fact that we want to configure everything properly and securely and making sure that configured is a great step forward when you try to establish security level or decent or adequate security level for your cluster, but it's not enough. Because you need to take into consideration also the application code. You need to take into consideration also the communication, who's exposed, who's not exposed, what vulnerabilities your code has or doesn't, or what are you bringing into the infrastructure. I'm not talking about applicative attacks that if you forgot to validate the input or the output, or if you got password. I'm talking about vulnerable applicative code which is exposed to anyone else who can use it. We heard about different recent attacks. All of them can also serve, even if everything is configured properly, they can serve as an easy ladder or an easy leverage to get into the cluster. And I think those has to be also put into the right consideration, the right context. And of course, I think the big word that I'm missing in all those tests is the context. What is the context? There's a lot of tests covering a lot of elements, and we want to know what is the context. How does it relate to me? How does it relate to my security? What can be done if I fail this specific test? Or what is it terrible? Is it not so bad? I mean, can I live with it? Or I need to fix it tomorrow morning? And I think the context is what bothers us, at least when we try to think about something which is more comprehensive and provide a better security overview for our users. And those were one of the reasons that led us to consider the MITRE ATT&CK matrix. And this is why we chose to look for a different path. And just to refresh the audience memory about the MITRE ATT&CK matrix. So it's a comprehensive knowledge base, of information that contain a lot of tactics, different tactics that attackers are using, okay? Trying to get, the ultimate objective of an attacker. It also consists of techniques, so it's tactic and techniques, and it's all based on real data, on data which was collected from an attack, and it's covered the entire attack from A to Z. So it's not just, accessing the initial access. It's not just the exploitation. It goes beyond it. It goes all the way until, I would say, the entire attack spectrum from A to Z, all the different stages in everything. And in this big spectrum, there are pillars, and each pillar carved the specific techniques or tactics which are used to achieve the goal that it's made. So without a little bit more talking, let's, go into a little bit more details and try to explain what it is. I'll skip just one slide. So I don't know if it's visible here. I'm sure, Zohar, you're going to show it better in our demo, but you can see those pillars right over here. There's initial access, the execution, persistence, privilege escalation, defense evasion, credential access, discover, lateral movements, and impact. All those pillars are stages, okay, are stages in the attack. And what we were missing until now was the interpretation to Kubernetes. So how we can, take those, spectrum, how can we take this spectrum, and how we can convert it to Kubernetes and put in the right content of what does it mean in Kubernetes? What does it mean, when you're trying to attack a cluster as an atomic unit? And this is, why I think, what's the big motivation that was behind our K-Shield. And K-Shield, okay, this is our attack style framework. So it's a MITRE ATT&CK matrix, which is interpreted to Kubernetes, lists a lot of security checks and tests that validate the Kubernetes cluster security posture based on the entire, attack spectrum, or what we call the attack anatomy. Okay, it's proactive checks. Okay, and we're using the matrix format, so every stage is detailed and consists of multiple techniques which can allow an attacker to achieve the goal. And for every technique or every tactique, we discover whether it's applicable to the cluster itself. And if it is, we also suggest or remediate, or whatever the mediation, what would be the best way to mitigate the potential risk. So it's not like something related to Portshift, it's related to how you configure, what you need to change, or what policy you need to set in place, or what role-based, what you need to change on your role-based access control, or what are things that you want to remove, if there are things which need to be removed from your cluster. So all of it together, aiming to give you a real-life, actual security status, give you the entire spectrum covering all the different aspects of potential attacks, and give the user the understanding where he is, or what are the things that matter, and what are the things that you need to fix first, or if there are things which he doesn't worry about because you know that they are fixed, he doesn't have to worry about them when it comes to the technique. So the entire security context is the one that is playing into the game. And as I said before, you can see this diagram over here, and I'm sure it's a bit hard to see. We're trying to fit it all in one screen, but in a moment we'll be able to see all the different tactique and techniques in action. So this is on our motivation. Zohar, what do you think about that?
So, I think that the MITRE mapping is a great thing, to show how you are vulnerable and how your clusters can be actually attacked. So all the attack vectors are visible. So we did try to map for customers these vectors and also show them how they can easily remediate the issues and actually be more secure and resilient to the attack vectors.
Great. Perfect. So let's go to the slides. Let's go to the real demo. And the first thing is I would like to talk to you about, the recent vulnerability. I mentioned it before. We got CVSS score or 7.8. It's not 10, but still, nevertheless, it's a notable CV. I think it's one of the most notable CVs. And if it uses, Linux kernel memory corruption, and if exploited, it allows a potential attacker, to use this memory corruption to gain root privileges from an unprivileged container. And I would love to hear, based on the idea that all these vulnerabilities or all these privileges has to be managed. What do you think are the way to control that?
Yeah, so this is like a very important vulnerability, and I think that the way forward is by combining controlling the security context and other measurements. What do you say, Ariel?
Yep, and I think that's the right way. That's the right approach. I definitely think you need to look at it and examine it from the very beginning. So let's check what you can do.
Great, so I'll share my screen. So let's see, share screen. And so hopefully you can see the MITRE framework as actually we program it in our product. So there is also a generic dashboard that we will see in a moment, but this is the MITRE framework, and this is a demo class. Yes.
Your screen is blinking.
Really?
Or at least for me. Okay, maybe it's mine.
I can stop sharing and try again. Wow. Let's see. So having multiple screens can come to our aid. So let's share this one.
Great. So in the meantime, okay, much better now. That's perfect.
Yeah, so now it's not blinking. So this is probably the better screen to use. So now you can see the MITRE ATT&CK framework as seen in our product. There are all the categories that Ariel explained about, all the attack vectors, the initial access, the execution, the persistence, privilege escalation, defense evasion, credential access, discovery, lateral movement, and impact. But we will first concentrate on the vulnerability that related to the security context, and we will see, how we can mitigate this. So what we'll do, we'll apply a simple YAML file. So let's see the YAML file here. So this YAML file will allow privilege escalation and root access. Just as a note, this is by default, this is actually allowed. So if you're not writing anything in your YAML file, then automatically these actually the security context includes root access and privilege escalation, which is less advised. So we are using that sort of YAML file. So I'll just apply this YAML file. And now we configured a curl demo. So this is we'll see this pod in a moment. So here in the product, you can see a list of all the pods, and we will look for a curl demo. So you can see it, and this is you can see there are two ones. Actually, one that I stopped using, previously to the demo, and one that is active. And the active one, like you see, has a critical risk attached to it. This is because the workload is privileged, like I promised you, and it can run as root. So this is, a view here, but we all came to see the Kubernetes MITRE dashboard. So this is the Kubernetes shield. So you can see here the Kubernetes shield, and you can see that, for example, for privileged root, there are lots of pods because this is a noisy demo environment, and the last one is the curl demo that we have. And there is you can see the same thing, so privilege root and also in privilege escalation. So all the way down, it's also there. So there is a very simple way to remedy that. It's just loading the pod with better credentials or better security context. So let me show you the new YAML file that I plan to apply. So it's a long YAML file, but at the end of it, you can see that in the security context part, as user is specifying user 1000. User root is numbered by 0, so this is non-root. And allowed privilege escalation is set here to false. So not sure that I convinced you, but this is a much better YAML. So let's apply it. So the YAML file was applied. And now it will take you a few seconds for the new pod to run and be up and running. So let's search it again. So we will look again for curl demo. So again, there are two ones, but my pod is not yet active. So let's refresh. Now it's active. So you see the old one has a critical level of risk. It's unhealthy because it's terminating, which is not surprise, but no surprise. But the new one has no risks attached to it. And indeed, if we go to the Kubernetes Shield dashboard, so we can look at the privilege escalation, for example, or the root pods, and we will not see, all the way down, we will not see curl demo again, also here. So if it was a much cleaner environment, then probably I would have seen a green V. But in any case, I could do the same and harden the security context for all others as well.
Thank you, Zohar. This is a great point, and I think should be noted. Would you say that basically you don't need to wait for vulnerability, because in the security context, the default value for privilege escalation is true. And if you don't explicitly specify the process, which is not 0, then by default, escalation can happen, maybe not to root, but definitely for privilege. And even without this CVE, we can reach dangerous situation. And, in general, the security context is, regardless of this CVE or regardless, is something that needs to be taken into serious consideration, because, escape or, breach can make, much bigger impact. You're running as a root or as privilege and not as regular. And this is, I think, is a critical point. And the beautiful that by seeing it all the different workloads, we can understand, where we are exposed, and where we forgot to change the security context or didn't use the pod security profiles, which we talked about, I think, in our previous talk. And that's a great point. Yes.
Yeah, I fully agree with you. Having pods run as root is one of the most insecure things that one can do. A root pod can also access the node, can access various other things that you probably wouldn't like it to do. And we really encourage you to configure your pods without a root access or privileged access.
Perfect. So let's move to the next, our next challenge. You talked about people, forgetting to change the security context. Let's talk about some other, I would say, very popular misconfiguration. And let's talk about a little bit about the popular Kubernetes attack. So early in 2018, when the first Kubernetes attack happened, we found it was due to the exposed dashboard. So whether, at that time, before Kubernetes version 1.11, the dashboard, the Kubernetes dashboard, which has cluster admin capabilities, was either, exposed without any, login. So everyone who can curl into the dashboard can do anything that the dashboard allow, and pretty much allow everything. And even when the login or the credentials were required, they could have been skipped. So you can skip them and then bypass the need to authenticate. And this led to some of the famous attacks. It was early days, 2018. We thought it's past. But what caught my mind was that recently there were some interesting notes coming from the Azure Security Center, which is doing really a great security job, and they detected large-scale crypto mining currency or cryptocurrency mining, that targeting Kubernetes clusters. And Zohar, guess what? The main attack was the same thing. People left their Kubernetes exposed, which is quite hard, after 1.11, that you really need to add kind of token when you do it. But eventually, guess what? It's still there, and there's something from, you can see April 2020. That they detect this large-scale mining that happened in Kubernetes clusters, which left it exposed. But more interestingly, and this is something really interesting that I found, was this note from the same researcher talking about misconfigured kubeflow. And that's really interesting, because kubeflow came with default set. Kubeflow, just as a short background, is a popular machine learning framework that operate those tasks in Kubernetes clusters using its service mesh. It uses usually a high capacity nodes. And the interesting thing was that it can configure properly. That that the Kubeflow dashboard was really behind ingress gateway that has a specific policy that restrict the access. But apparently, what a lot of users did, they just said it's too hard to create this, tunneling, and I need to use local host and everything, and just open it behind the load balancing service. It really exposes it to everyone to access it from wherever they are. And unfortunately, not only the legitimate users deployed it, what they discovered was a large campaign or large scale of exploitation on those interesting Kubeflow dashboard, which again are, when we talk about Kubernetes dashboard, you can tell me, you can look at the label Kubernetes dashboard. It's easy to detect. Today in Kubernetes version where we are, it's even a little bit much more secure, so it's really hard to keep it. But what do you think about detecting applicative dashboard? What do you think about that? What do you do? That's a common popular misconfiguration. How can you verify that?
So regretfully, it is indeed one of the most scary things you can imagine. You just do a tiny misconfiguration, so one YAML file, one line in one YAML file that is misconfigured, and you're open to the world. We see a lot of these cases, and we will also show you in the demo, of course. But this is indeed one of the most scary things that an administrator can have a mistake in.
Yeah, in this case, not even the administrator configure it correctly. It came afterwards. So please show us what can be done.
Sure. So I will not. First of all, I will show you something from previous talk. So for our constant viewers, it will probably be familiar. So this is a site, shodan.io. You can search for dashboards that are open to the world. So for example, here, this is a search for WeaveWork dashboard. And regretfully, you will find many of these. So it's not something that we tell you that about something that nobody actually happens to. It happens every day, and WeaveWork dashboard is a very popular one, and it just shows you that it is not happening only to the Kubernetes dashboard. It can happen also to other applicative dashboards that are as powerful as the Kubernetes dashboard. So we need to have somehow.
This is the real trick. How do you catch those things which you don't even know that they are dashboard? They don't have a dashboard label on them.
Yes, that's correct, and this is indeed challenge. So in Portshift, what we did, we tried to divide the problem into two. The first part is the Kubernetes dashboard that you can, you will see it in a moment, and the next one is sorry, here. So now you see it. So the Kubernetes dashboard, and the next one is applicative dashboards. So applicative dashboards can be a dashboard like WeaveWork, like the Kubeflow dashboard that Ariel just mentioned. And we actually recognize them according to the strengths they have, the permissions, the role-based access controls. So we see a pod that has too much power, actually. So this pod is very strong and can do many harmful things to your cluster, actually control almost every aspect of the cluster. So for every pod that is so strong, we consider it as an applicative dashboard, and we treat it as such. Okay. So let's see, so you can see here that exposed applicative dashboard, everything looks okay. So we are not suspecting, we are fine here. While in the Kubernetes dashboard, we alert on it. So why is this? So let's first see both dashboards. So we have here installed the Kubernetes dashboard and the Kubeflow dashboard. So you will see in a moment both of these. So the central dashboard, this is the Kubeflow dashboard. You can see that the level here of risk is critical because it's run as root. It is public facing, and it has privilege escalation, if you remember the previous demo. This is the settings by default of Kubeflow. We just apply the default, and this is what we've received, which is not ideal. While the Kubernetes dashboard, we treat it, as better. It's only public facing, and we will see in a moment why the risk is lower. Actually, the reason is also the remedy. So we will see we have a connection policy, and in the connection policy there is a rule that is blocking access to the central dashboard from the external world. So now the central dashboard is not exposed as we've seen in the Shodan side for WeaveWork dashboards. So we closed all access to this dashboard. So now it's not visible anymore from the external. This is why also, if you remember, the applicative dashboards was a green V. While the Kubernetes dashboard, we can also block access to it now, just to be on the safe side. So we can add here the Kubernetes dashboard. And the source was external, and the rule is block. So we are blocking all the communications toward these two dashboards. And now I can apply the policy, and we will feel much safer here.
That's a great point. And I think, this is a great point where the network policy can augment for misconfiguration or challenges in the deployment of the pods and keep you, on the safe side. So thank you, Zohar. This was really indeed super interesting, how you detect applicative dashboards. Kubernetes, you can always say you can look for it, but applicative is something which is hard to know, and how you can really leverage the usage of your network policy to come and complement, the deployment settings and the different findings. And this is, brings me to the next thing. So we talked about, different attacks. We talked about, things which are popular in the news. Let's talk about something, for me personally, is always something, that bothers me, because at the end of the day, if someone can be a cluster admin, and this is something which relates to the permissions. Who owns the keys, to your safe, or who owns the keys to your cluster? And this is, the cluster admin. The cluster admin is probably the most powerful role. Is the role that you can really, has the keys to the kingdom. And tell me, how do you secure that? How do you detect issues, or how do you secure making sure that the keys are on the right hands and not shared between multiple users? This is something, for me, is always an interesting thing to look at.
Yes, very good point, Ariel. When you give someone the ability to be your cluster admin, they can actually do anything. They're even more dangerous than a dashboard, of course. So you need to be in control of who are the admins, and if there is an excessive admin, you can just remove these admins. And our tool will show you in a moment in the demo with the list of admins, and of course how you can also control this by policy and not allow new admins to be created by the almighty powerful cluster admins. So we'll see that in a moment. Are you ready, Ariel?
Yes, I'll be excited to see that. Let's go.
Cool. Okay, so you can see again my screen where we left it. So let's return back to the Kubernetes shield. This time we are focusing on cluster admins. So you can see here in privileged escalation. So there are cluster admin binding. We have here a clean sheet. While there is in the cluster admins, you can see there is only one, the cluster admin, which is our cluster admin. So first of all, this is, of course, our only cluster admin. So this is probably OK. You shouldn't be worried about it. So we have a system that is analyzing all the permissions in the cluster. And we can also say to the Kubernetes shield that this is actually a valid cluster admin, and we are not we can approve this one. So we can look at it and just say this is OK. So we'll do that in a moment. So we'll just search for this role only because this is a good admin. If maybe I should have used the wrong. What did I do wrong? So never mind. We'll keep it as is.
Right. Maybe perhaps Zohar, you can show me, how you can restrict, more cluster admins, or how you can avoid others from becoming a cluster admin, even they manage, to bypass the regular checks.
Sure. Let's do that. So let's go back to our favorite screen. the command line screen, and let's apply the YAML file that will create a new cluster admin for us. So we'll just run this one. And a new cluster admin binding was created. So now if we go back to our dashboard, then we will see in a moment. Okay, so we will look now at the cluster admins. And we will see that the curl demo role was added to the cluster admin list. So this is something that we want somehow to control, because maybe we are not allowing new cluster admin to be created without our permission, which is not not ideal. So it just to show how this is done, let's delete this cluster admin. So we'll revert it back. Add a policy. So now this admin binding is deleted. Now add a policy that will prevent this mishappening. So you can see here I have in the policies tab, I can have an event rules. So I already prepared an event that is disabled, but let's look at it first. So we have lots of presets that can do the work much easier for you. We can, of course, be very granular and disallow specific API calls, but we have presets like the prevent cluster admin binding here that will just do the work and be very readable as you see it now. So what we did here is prevent cluster admin binding. We can set the scope to be on the whole cluster or on a specific environment here, the demo environment that we use, and we're blocking that. So we'll just enable the rule now. So enable and apply. And now what we expect is that creating new cluster admins, although of course I can do that. I showed you in the command line that it worked just a few seconds ago, but it will not be successful anymore. So let me just switch to my favorite screen. And now let's just apply again the YAML file that we just previously applied. So this was the apply. And like you see, when we try to apply, there is an error. The error is that Portshift actually denied this because it was blocked by our policy. So even if I'm the MITRE cluster admin, I cannot create new cluster admins because this is not compliant to the organization policy. And this is very important, and this can be very granularly controlled, like we have shown now.
Well, this is indeed super impressive. And indeed, looking at the permissions and monitoring and governing, this is something that definitely contributes. So Zohar, I think we're a little bit, we're running a little bit over time. We're starting to plan. We have a lot of more demos. We'll probably kind of be a little bit more selective on the next few demos. We covered deployment and security context like we did before. We show how the network can come to our rescue when there are some misconfiguration. We talked about permissions. And I think, between the thing that for me will be interesting to see is things which are more related, to the cluster or not that specific pod or specific elements. And what I have in mind is a lot of times, we see attackers trying to hide their tracks or trying to hide signs or sign that they've been there or they died it. And we also saw it in some interesting, crypto mining attacks that the attackers were really hiding, behind, the scene, making it very hard to detect them. So one of the pillars, that in the MITRE ATT&CK that we had a lot of research called defense evasion, is, how you can hide your track, how you can hide things. What do you think about that?
Yes, so let me show a demo of how you can actually prevent defense evasion, which is also very important. So you can see my screen again, and this time we will apply a YAML file that will actually. So first, before applying the YAML file, I'll show you the dashboard again. So in the MITRE dashboard, we have a section called Defense Evasion. So Defense Evasion has two parts. You can either clear the container logs, allow or disallow, so this is okay now. In Defense Evasion, we can see that there is already one pod that might be able to update earlier logs, or that this can be considered as a defense evasion. So this is, not advisable to run such pods. So first of all, we will deploy a new such pod. So we will return back to the command line and apply the YAML file, of course. So this YAML file will actually will create a new permission for us to do exactly what is forbidden, which is to delete logs, older logs of Kubernetes. So, so let's see if it successfully was created. So you can see that curl demo, again, I'm using the same curl demo every time, is now created and has the ability to do defense evasion. The way to work around it is, again, in our policy. So we can do cluster event rules and actually prevent defense evasion. So you can see here such a rule. So we can prevent defense evasion, and we can choose the clusters or environment that we want to deploy that in, and again, choose block. So this is, in general way, even if bad roles are created, then we will actually defend the clusters and will not let any such role delete the logs. So let's just, remove this RBAC. And in parallel, just because of time, I'll show you something not less interesting, which is so we'll see in a moment that it was removed, but we will also apply a different YAML that will actually deploy a pod that has SSH open. So this is, again, very dangerous. We have a pod that someone can connect from remote and do SSH towards this pod. So let's see these two. So first of all, let's go to the dashboard, and in the dashboard, let's look at the defense evasion, and we can see now that the kernel demo is not anymore there because we removed this bad role. Now let's look at the SSH. So I just run a pod named SSH. So let's see that it's up and running. Okay, not yet.
Okay, so maybe you could talk about a little bit about, yes.
And you can see, this pod is running, and it has port 22 open. So for each pod, we monitor that. It's not public facing, so it's less bad than others. But this is, will show immediately on our Kubernetes dashboard. So you can see here again the workload SSH that is here. And now let's see how we remedy it. So actually the best way to remedy it is not to run such pods. So we'll just delete the pod, and we expect, after deleting it, that the pod will just will not be existing here in the workload table. And also in the MITRE dashboard, we expect it not to be noticed anymore. So here we see only the CLI pod, which was already here, but SSH pod is gone.
Right, and that's, I think this is indeed a really critical feature to show which of the pods can be accessed using an SSH tunnel. And thank you, Zohar, also for adding it into. And again, I think all of it is kind of piling up to combine all the different aspects of attack. We don't just look at some element, but you look at it throughout the initial access, the exploitation, the privilege escalation, and then all the way through until defense evasion. We can also talk about impact, and there is many more. But given that we have some time constraints, we want to leave some time for audience questions. So let's just maybe perhaps summarize it, and then we can leave the last few minutes for some questions from the audience. So I think as Zohar, and I think you showed it very nice in the different demos. There is the need to understand what are the cluster vulnerabilities and what are the risks. And sometimes you see many vulnerabilities, but don't understand the whole chain. You don't understand where it fits in the entire chain, and getting this visibility, I think it's critical. This is what I consider the security context. How do you see the context of all your security, all different elements, and how it's all tied up together? And then, always you need to ask yourself, not just get the vulnerabilities, but how can I remediate it? And I think Zohar did a great job in showing how those things can be remediated. Before we just turning to questions for the audience, just want to wrap up. So everything we showed is available on our website. We wrote a detailed blog. We of course invite everyone to download it and get more details. We also invite you to, in the same website, to register for a free trial or a demo. And always, you can leave your name, and we'll be happy to get back to you and answer any questions or provide you the material you're interested in. So by that, I would like to open for questions. If there is any question from the audience, Zohar, I think we can spend a few minutes answering questions. But until that, I want to say thank you for this beautiful demo and for the very knowledgeable. It was really super interesting. And I see some interesting questions coming from from the audience. And this is something just maybe like cluster admin and like roles, something that can be interesting as well. This is the secrets. Because secrets, it's a very powerful mechanism. It allows you, not to store anything on the disk. But on the other hand, if someone has a kubectl access to the cluster, if it doesn't have the proper permission, it can definitely list and get to see and watch. What do you think about that?
Yes, so secrets, are very, I would say, delicate part of the Kubernetes system. You can, people actually rely on that. They put their credential to access their AWS, their Google accounts, and other, sensitive assets. And they need to have control of who can access these secrets, because otherwise you're fully exposed. And Kubernetes is not actually the target of the attack. It's actually the means to attack your crown jewels, which Kubernetes might have access to. So this is something very dangerous and must be controlled.
I agree. And here's some other question from the audience, Zohar. What do you think about lateral movements? What would you do, to prevent this pillar?
So, maybe it was not evident from my previous answer, but both secrets and lateral movements can be actually, the risk can be mitigated with our product by defining specific policies that will actually say what's allowed and what's not allowed. So in lateral movement, you can just specify which namespaces can access each other or an external entities. And also in secrets, you can specify exactly which pods or which users can access secrets, and this is really highly recommended.
Perfect. So you're saying that the idea or the essence is defining right policies, creating the right boundaries, and not just leaving it communication free between all the different pods in the cluster or all the different services. Yep, and I think this answers up. So if there are no more questions, I would like to thank you for all those great demos.
Sure. Thank you, Ariel, for actually initiating this in Portshift. And now you're actually the originator of it, and it's a great dashboard that we've seen today.
Great. And how we encourage users to come and test it. And as I said before, please visit us and portshift.io. We'll be happy to share and show and let you experience it yourself. Thank you, Zohar. Thank you, everyone. Thank you for joining. And have a great rest of your day.
Till the next time. Bye.
Bye-bye.